dia a todos, bem-vindos. Este é o 16º SIX Talks. Eu sou Vanderlei Jones, sou um dos coordenadores do SIX, Centro de Inovação e Construção Sustentável, uma iniciativa da Escola Politécnica da Universidade de São Paulo, que reúne acadêmicos e empresas interessados e comprometidos com a inovação. Nós estamos dando, com essa live, mais um passo na discussão sobre a questão da construção industrializada e a construção modular, né? Nós já fizemos 3, e todos esses eventos estão gravados e disponíveis no nosso canal do YouTube, SIX USP. Né? Hoje nós temos muito prazer em receber o professor Masa Noguchi. Ele é muito conhecido aqui no Brasil, tem vindo frequentemente, mas é uma das grandes cabeças, né, por trás de repensar fora do Japão essa questão da construção modular. Ele vai apresentar a palestra em inglês, The Essence of Japan's Industrialized Housing Business Operation, né, a essência da experiência japonesa de construção industrializada. Né. O Japão começou isso muito antes de todo mundo e tem uma parcela bastante grande do mercado imobiliário, né, operando na forma dessa construção modular, né, com o uso de robô, e tem empresas que fazem 50 mil casas por ano, cada casa custom-made ao gosto do cliente. Né. O professor Masa, ele é professor de design ambiental na Faculdade de Arquitetura da Universidade de Melbourne, né, e ele criou e coordena uma rede internacional muito ativa, que eu recomendo que vocês visitem, está disponível no LinkedIn, Zero Energy Mass Custom Home, né, que engloba a discussão de pré-fabricação, casas eficientes em termos de uso de energia, né, Zero Energy, né, e customizadas, produzidas de acordo com o gosto do cliente, né. Então, essa é uma visão do professor Masa, e ele tem andado pelo mundo apresentando essa visão. Ele é engenheiro, né, especializado em design e meio ambiente, né, está registrado nos conselhos de engenharia do Canadá e da Inglaterra, né. Ele também, essa rede dele tem hoje 799 parceiros em 40 países. Em 2006, ele projetou a primeira casa modular Zero Energy no Canadá, chamada Ecoterra House. Vocês vão encontrar informação sobre essa casa na internet. Construída e comercializada através de uma competição que houve no Canadá, chamada Equilibrium, financiada por o governo, que buscava incentivar a inovação de baixo impacto ambiental no setor imobiliário. Né. Hoje ele colabora com universidades e construtoras em projetos de P&D, né, com essa visão da Zero Energy Modular Construction, né, tanto no Brasil quanto no exterior. Para a gente, antes de passar a palavra para o professor Masa, eu queria registrar aqui o apoio, né, constante da Poli, né, o SIX está hospedado na Poli, né, do Departamento de Engenharia de Construção Civil, da Cátedra Construindo Amanhã, que é mantida pela ArcelorMittal junto com a USP, reconhecer o apoio da Universidade de Melbourne. A gente também tem sempre o apoio na divulgação do CBCS, Conselho Brasileiro de Construção Sustentável, e do site Construliga. Né. As perguntas, elas vão estar acessíveis a todos durante a palestra, no chat, né. Não temos como abrir o microfone para todo mundo. Vocês fazem a pergunta, por favor, se identifiquem, sempre é bom a gente saber de onde são as pessoas, né. E elas vão ser respondidas pelo professor Masa depois da sua apresentação. Bom, obrigado pela presença de todos. Masa, thank you very much for coming again. It's not your first time at USP. You're always welcome, and you're always very generous sharing your knowledge. So the floor is yours. Please, thank you very much.
Thank you very much, Professor Vanderlei John, having me today. And thank you all joining this webinar. It is great pleasure to deliver this talk about my research on Japan's prefabricated housing business operations. I'm going to share the screen now. Okay, so today's presentation is based on the data collected over the last 22 years also, and particularly my visit with a number of international delegates, and many from Brazil as well, in order to scrutinize the state-of-the-art production and sales facilities of leading housing manufacturers. The success of Japanese prefabricated housing business is fundamentally derived from multi-companies collaborations rather than pure competitions in order to introduce their innovations, and their collaborations usually carried out through well-established associations, which is known as Japan Prefabricated Construction Suppliers and Manufacturers Association. We usually call JPA. That is the acronym. The JPA was established in January 1983. Today, 227 companies, small-scale companies, middle and large-scale companies, they work together to share the experience and revise their technical knowledge and penetrate the mass market with collaborations. This indicates the housing ratio to housing starts. Yellow portions, housing start, and blue portion represents the housing starts. In 2018, 942,370 homes were built in Japan. Among this figure, 131,496 homes were considered as prefab. This implies 14% of housing starts were considered as prefabricated homes. These are companies which we visited in the past. Some of them are quite familiar to all of us. Toyota, Panasonic, they also built Home Japan. JPA distributed nearly 4,000 questionnaires in order to extract the reason why their consumers prefer to purchase industrialized house. According to their result, 22% of the respondents were pretty much comfortable or perhaps very appreciative of reliability of large-scale company. But this reason doesn't reflect their product quality. Unlike the following the parameters such as superior or product quality and performance, earthquake resistance, altogether 35%. The red point, 9% altogether, a reflection of their design. Okay? Japanese housing manufacturers focus on quality, psychological quality, product quality, and design quality. This is a very important aspect. Focus on the quality. But very interesting things right here is 2% of the respondents see the prefab as a relatively low price. Actually not. Prefab, in principle, it's more expensive than conventional homes. Well, this tendency was observed in the countries which I studied and lived in the past, Canada, UK, Australia, today's, and all of them tend to be more expensive. When I survey this price, 8% more expensive than conventional one. Nonetheless, 98% of the consumers who prefer to purchase prefabricated homes, they're happy with the quality given, product quality, design quality, and psychological quality. In order to achieve their psychological quality, Japanese housing manufacturers, they implement various modes of advertisement, as you can see, TV commercials and local media, newspapers, and so on, in order to turn the company's names into brand. People can recognize that is brand name effect. High brand is equivalent to high quality psychologically, secure, perceive their credibility. So that is their brand name effect in order to secure psychological quality. On top of that, in order to allow the users to actually experience or understand, appreciate product qualities, Japanese housing manufacturers offer housing parks and housing information centers. These places allow the users to experience their product quality. So in order to introduce innovations, it is very important to think about psychological quality as well as product quality through the experience. This is the housing park based in Tokyo, which I visited in a distant past. A relatively small village, display village, 8 model homes built by 8 different housing manufacturers. If you visit that, you feel very comfortable atmosphere. Doors opens and welcoming features, and you can enter the model homes, and inside the model homes and salespersons are usually waiting for you to enter and welcome you and show you around, explain distinctive features, and on top of that, they encourage you to visit other housing prototypes to compare, because each house has a different characteristics and features that is very important to be digested. So comparison is very important. I also survey the impact of housing park or perhaps user experience on marketing. I picked here 3 housing manufacturers here. Sekisui Heims, relatively large at the time, sold 17,990 homes at that times, a relatively old data, but tendencies are similar. And in terms of their possession of model homes, 711 model homes they had nationwide. Panahome, today they call it Panasonic homes, they are quite middle in terms of the number of model homes they possess, 380, as opposed to Resco, only 17. But having looked at their sales to model housing ratio, namely A divided by B, the Resco achieved 23, and Panasonic, Sekisui Heim, 26 and 25. In real terms, it's not much difference. The difference among them are relatively marginal. Okay. This, to some extent, gives us message. The number of model homes you have may have marginal effect. Of course, it has an impact on sales, but it's marginal effect as opposed to having the model home itself. So when you want to introduce innovations, it is very important to provide the users with experience, opportunities to experience their product quality. Daiwa House is pioneering company. They started introducing prefabricated homes in Japan. 1952, pipe house, there was shed. It's not really habitable, unlike a midget house, which was children study place, which you can assemble on the garden within 3 hours. That was a huge success because of their baby boomers. Therefore, 1959, this year is still considered as a benchmark year for the start of prefab in Japan. And after that, 3 years later, Daiwa has expanded business operations, subdivision development, mass housing development, all house were prefabricated house. And following year, 1963, JPA was established. And 1960s, industrial housing flourishing in Japan, but they also started developing stigma, negative perception of prefab. The general public see prefabs with low quality visually because of the same house again and again, and monotonous and identical and mechanized. It's not for me. It's not for our backyard. Okay, kind of NIMBY phenomena took place. So in order to turn the stigma, in order to demonstrate to the general public, prefab need not be of quality, need not be of low quality. Japanese housing manufacturers launched a housing competition, which is called House 55. That became a turning point for housing manufacturers. Focus on standardizations, okay, not necessarily house itself, turning from their housing standardization to housing component standardizations, namely mass customizations. Japanese housing manufacturers implement structural typology 3 types, porcelain beam, panelized, and modular. In Japan, they call it modular as a unit building systems. Okay, 63 House, probably one of the largest housing manufacturers in Japan in terms of their sales. 63 House used to be a part of 63 chemical company, but separated 1960s. They produced 2.42 million homes as of 2018, all prefabricated homes. Furthermore, they started doing business outside Japan, UK, US, China, Singapore, Australia, which I live in. Last year, Seki House already started introducing zero energy house. They claim they produce industrialized zero energy mass custom homes. Okay. They indicate their house comprised of 60,000 housing parts and components, 95% automated production lines in some factories in Japan, using robotics. And interestingly, they stress the fact that they practice 100% waste-free operations, not only inside the factory, but also outside. Okay. Seki House produced zero energy house. 85% of newly built homes were zero energy. Between April and July 2019, Between 2013 2019, 47,575 homes were prefabricated homes, reducing 160,000 tons CO2 emissions, reduce or eliminate negativity on climate change, global warming issues. In Japan as a whole, about 15% of newly built homes delivered by major housing manufacturers can be considered zero energy homes. But that figure came from 2018, 60 House excel in the delivery as opposed to other companies. But this year, a government expected all newly built homes, not all, 50% of newly built homes would be zero energy, delivered by major companies. But in real terms, actual figure, 70% of homes being built by these major companies already deliver zero energy house. You can find more detailed information, the data published by Sustainable Open Innovation Initiative organizations. You can find their company names and the exact data as well. Sekisui House stress this technology applied to zero energy house delivery, but I want you to bear in mind, all housing manufacturers, they deliver homes equipped with high performance insulation materials, airtight construction. This is already known. Okay. Some house equipped with the batteries, a fuel cell or CHP. If you introduce the CHP, combined heat and power, this case is a size of a PV can be reduced. But today, most of the housing manufacturers install PV and HEMS as a standard equipment. HEMS is an abbreviation of Home Energy Management Systems. I'm going to talk about both features, PV and HEMS. This is the display house, which we visited during Zenith mission to Japan in the past. As you can see, this is the rooftop exposed to the sunlight. It looks like ordinary roofing materials, but actually not. This is PV. They call it building integrated photovoltaics that reduce or eliminate the eccentricities associated with renewable energy technologies. And behind it is a tough roof. Greening the space and a PV, a quite good combination because PV doesn't like heat. The higher the temperature of PV, lower the efficiency. Therefore, the atmospheric temperature should be reduced, and green roof contribute to that because of the evaporations. Then greening the space, attract the insects and observe the CO2, release the oxygen and relieve our eyes and stress societies, and lots of benefits having green roof. And this is the HEMS, Home Energy Management Systems, visualize energy profile. But Japanese housing manufacturers usually use a common language or common units. Although they want to impress their potential clients with scientific units, kilowatt hours or megajoule, but lay people or families, they don't pay attention to that. If you show it monetary value, how much money this PV generate, income, how much money the house consumes now, this kind of information definitely affect the user behaviors towards energy saving, which is very important, behavioral change. HEMS is not only used for energy visualization, but also used as their systems for remote controller, remote controlling. For example, switch on and off, lighting, aircon, electric door, etc. etc. After you left the house and you can see their mobile devices, the lights is on, you can switch off. When coming back to homes and 5 minutes before arriving homes in hot summer time, you can switch on aircon and the indoor temperature become relatively comfortable. And watching TV, living rooms, and somebody knock the door or ring the bell, you can see who arrived. If some salesperson is not interested, you just mention, oh, we are busy, I'm not interested, thank you. But if your friends or family member arrive, you can unlock the door so they can come in. Today, Japanese housing manufacturers, they started using HEMS not only their energy, environmental system, but also more social networking systems. They call it watch and protect. 3:30 p.m.s and the lights, the children rooms lights on. So that means you can receive a message. Oh, my kids came back. You are on a Fiji island vacations, and then the lights on. That give you warning. It's better to call neighbors or police stations to check your house. This is quite new approach to energy consumption, so social networking and watch and protect, safety reason too. Furthermore, many housing manufacturers expand business operations, but in this case, Daiwa House, robotics, they developed crawl space inspectors. Previously, human workers enter this crawl space and with a torchlight and check their water, the pipes and termite presence, but it's a really easy job. But nowadays, it's replaced with robots, much easy to enter and get their information precisely. Why this kind of information, even after occupancy, is required? Because Japanese housing manufacturers, they have a confidence to produce quality homes. Therefore, they offer long-term warranty. This also helps reduce their potential consumers, reduce the risk of purchasing their innovations. I collected this information 21 years ago when I visited Toyota Homes. But 21 years ago, they already offered 20 years warranty, unlike their building regulations, and their usual warranties are 10 years. But most of the housing manufacturers, they offer much longer than obligations. Today, the housing manufacturers say, no, 20 years, 30 years, it's lifespan. They come to your house after turning key, 2 months later, 11 months, 23, 5 years later, and every 5 years, and 25, and every 10 years, and free inspections. Japanese housing manufacturers get in touch with you in order to collect their information because of their user who actually live in their house are good samples. Actual voice, and they are welcome to receive claims and understand the defects and bring them into a continuous improvement of product quality. Sekisui Heimin is another company which produce modular construction. They call it unit homes. And more than 80% of housing components manufactured inside the factory. We visited their production line almost annually, and this is their unit assembly sections, but to me is kind of museum. I can't find any tools or materials on the floor. It's very clean and actually efficient. The workers bring their tools, bring to the workplace, and after they finish it, bring it back to them. So they don't spend time for looking for tools. It's fundamental, but it's very important. Yeah. This is the wet rooms, kitchen, bathrooms, and this is the roof assembly. But more importantly, I think here is a display. They indicate today no 365 units need to be assembled, produced, and 76.5% already completed. 2.9 hours required to achieve the norm. So all the information shared by their workers inside the factories, therefore they can adjust their workabilities, the speed. Okay. This is the roof. Nowadays, PV panels installed as a standard features, not optional feature, standard features. Through their marketing strategy, which is called cost performance, turning optional equipment into their standard equipment. That is one of the very important their approach for the delivery of zero energy homes today. And after their unit is completed, each unit wrapped with their sheets for the protections and placed on their freight truck and transported to the building site, and exploiting unit systems. Sekisui invented or commercialized reuse systems, absolutely green approach. Their homes built using modular system, 1980s and 1990s, old house disassembled. Okay. Steel frame construction assemble and can be disassembled. Disassemble and put on the freight truck and bring it back to the factory and repair. According to them, above the materials above their foundations can be gone through their reuse systems. Their structural frames, 85% absolutely reused. Only 15% of materials needs to be replaced or recovered. This indicates before and after. Left-hand side is before and after. The house was expanded. The yellow portions, their units are added, probably multi-generation house. This case is opposite. The big house was reduced to small and provide the additional space, income generation, probably. Yeah. Because they reuse the large portion of the building materials, the selling price of reused system house could be reduced drastically. It's a 30–40%, but it doesn't imply their qualities has been diminished, because the higher the in-factory completeness, the better the product quality and better, of course, control, workabilities. Sekisui House claim they operate 100% waste-free operation, not only inside the factory, but also outside. Yeah. They established the recycling center, Eco First. Yeah. We visited, and according to their presentations on site, the materials generated, waste materials generated, they sorted out, they separated according to 70 categories and wrap it and package it, bring them back to their factory like this, and further separated according to 30 categories. And this gentleman demonstrate how the tatami mat can be disassembled. Yeah. This is a styrofoams and later chopped into the pieces and developed the ingot something like that. Their cables chop into the pieces and put into the water, thanks to Mother Nature's, and the light materials such as plastic can float, and heavy materials, the metals sink. This kind of separations turn the on-site materials collected into resources for income generations. If you collect the on-site waste and dump it, you have to pay. But if you collect and separate it according to more details and according to the materials turned into resources, the company can receive their income from it. Mass customization is one of the key features that distinguish Japanese housing manufacturers from on-site counterparts. Mass customizations standardize the components, volumetric, exterior, interior components, other components, and combine them. So this combination process can be done by making use of paper catalog. But nowadays, why not digitalize? This case is a Misawa. Digitalize mass custom design communication tools, exterior walls, interior walls, and put together to customize within the economic constraints. Due to the mass customizations, subdivision development can be grow more naturally. If you have a look at these houses, mass housing development, and every house, different colors and textures, but their rooftop are equipped with PV. Okay. Again, this is the subdivision development or prefab developed by Panasonic, and this is the internal components. It's the reflection of their user needs and demands. I'm going to finish my presentation with this summary. This extract essential approaches being applied by the Japanese housing manufacturers. Japanese housing manufacturers and mass customized end products, volumetric, exterior, interior components, as well as other components such as handrails, inclusive design, lift, renewable energy technology, but cost performance marketing strategy aiming to turn this optional equipment to standard equipment. Nowadays, a number of renewable energy technologies are installed as a standard equipment rather than options in order to deliver marketable, replicable, zero energy mass custom homes, ZEMIT, that reflect socially, economically, environmentally, and humanly sustainable built environments that satisfies needs and demands of individuals as well as society. I think this is my pitch of today. Thank you very much for your attention.
Muito obrigado. Professor Massa, thank you very much and hope to see you soon.
Obrigado. Thank you very much.